And sometimes there are some subtleties of maybe having some CH bonds, or maybe things like carbon dioxide at least are excluded. But fundamentally, organic chemistry is the chemistry of carbon compounds. And up until the beginning of the 19th century, people thought that there was an inexorable divide between organic chemistry and inorganic chemistry, that only living things could make organic chemicals. And in 1828, Friedrich Wöhler broke this paradigm and showed that he could make urea not from kidneys, not from a human being or a dog, but in the laboratory from inorganic chemicals. And that was a major paradigm shift. And then the chemical industry later on in the 19th century took off with the dye stuff industry. It used to be that all of the dyes for clothing could only come from plant sources and animal sources like shells and beetles. And then it was discovered that all of these beautiful chemicals could be made all of these beautiful pigments could be made in the laboratory, and now all of these wonderful purples and pinks and reds and so forth that we take for granted are relatively cheap synthetic chemicals. Health has always been an important part of organic chemistry, and in fact, the dye stuff industry came from a chemist's attempt, very crude attempt, the chemist named Perkin, to make a chemical compound that was used to treat malaria, quinine. Malaria was a big problem throughout the world. It still is in many parts of the developing world, not in the US right now, thank goodness. But quinine was the only treatment, and that came from the bark of a plant. And so Perkin tried to make quinine in the laboratory and instead got a beautiful purple compound. And being clever, he realized sometimes when you do an experiment and you don't get the result that you seek, you could actually do even better with the discovery that you found, and thus the dye stuff industry was born. Health has continued with antibiotics, with compounds to treat diseases like AIDS, and these are all products of the chemical industry. In fact, many of the PhD students who come through our program, like Johnny and Buck, will go on to careers in the pharmaceutical industry, helping to invent the next generation of medicines that fight disease. So I've mentioned some organic chemicals. I've mentioned urea. I've mentioned dyes. I've mentioned antibiotics. I've mentioned drugs to fight other diseases. What are some other organic chemicals? Alcohol, a great favorite. Later on, you will be learning about NMR spectroscopy, and the first NMR, not in our class, but in the B course, and the first NMR spectrum, nuclear magnetic resonance spectrum, the technique that now is very similar to the medical technique you've heard of as MRI, magnetic resonance imaging. The very first nuclear magnetic resonance spectrum was recorded on ethyl alcohol. What are some others? Ethane. We will be learning about ethane and other alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, dodecane, undecane, etc. When we start talking about alkanes, which I think is going to be either in October, I believe, and maybe be into November, that will provide us into a platform on some of the big concepts I'm going to be talking about. Some other organic chemicals. Sugar! Fantastic! Not only is sugar sweet, but it is an important component of many living systems. On the surface of cells in your body, there are sugars that are attached. Different types of sugars make you, literally. So in your blood group, whether you're A or B or O, you're going to have different types of sugars attached to your cell surfaces. And in turn, your immune system is going to recognize whether you have sugars for the A blood group or the B group, which is why if you're A, you can't get a transfusion from B, and if you're B, you can't get a transfusion from A. Sugars are also an important part of another biological molecule that is literally central to life, central to your genetic identity. What is that organic chemical compound? DNA. All right. Sugars, nucleic acids, DNA, and RNA are two of the biggies for biomolecules. What's the third biggie? Proteins. So, everything from synthetic compounds like antibiotics to alcohols to useful things like natural gas and all of the things that derive from petroleum, which includes the plastic and many of the fabrics in your chairs, your nylon backpacks, and so forth, are all coming from petroleum, to biomolecules like sugars and denucleic acids and peptides and proteins are all central to organic chemistry. And this is why, even if you aren't a chemist, it is so important to learn a little bit about organic chemistry. Well, today I'm going to give you the 3 things that you need to know for the entire rest of the year. Then you can take all your final exams and graduate.